Hi, everyone. Welcome back to Today in Tech. I'm Juliet Beauchamp, and I'm here with Ashish Nadkarni. He is a market research analyst with the infrastructure group at IDC. We are live on our YouTube channel, IDG Tech Talk. So if you have any questions or comments while we are discussing today, please do let us know in the comments below. I think we've got a super interesting topic on deck today. So Ashish, thank you so much for calling in. We're talking data center efficiency. I think data center efficiency is... I hear a lot of people talking about it, consumers and enterprise professionals alike, IT professionals alike, because I think it's a topic that sort of passes, from consumers and enterprise users. For example, I know on the consumer front, a lot of people are aware that, data centers are super power hungry because of, something like crypto mining, for example. But, enterprises, it's a really big concern. They want to make sure that their data centers are cool. They want to make sure that they're not spending too much on keeping those data centers cool. It's better for the environment. So my first question to you is just a little bit of background information. What's the deal with data center efficiency, and why aren't data centers super efficient?
Well, thank you for having me on the show, and glad that this is a topic of conversation, because there is so much to talk about here, and a lot of it is happening behind the scenes, and a lot of your viewers may not realize the dependence of the economy today on digital economy today on data centers. We all use phones, we use cars, we use pretty much everything that we use today relies on something in a data center. And whether it is a cloud or whether it is your own IT data center, the fact of the matter is data centers are here to stay. And the more digitized the world is, the more we move into this digital transformation and move into a paperless economy. Data centers are what will power that economy, and any blip in that can bring the entire world crashing down. Whether it is the way in which we do business, or whether it is the bourses, or whether it is our phones connecting to the internet and what have you, the entirety of the world's economy runs on data centers. Now, data centers are here to stay. Many times people don't know that these data centers are what lends our the quality of life, if you will. And they are kind of like the automotive sector. We all drive around cars not realizing how inefficient they are, or how much of greenhouse emissions they create. But we cannot get rid of them. We have to rely on them to go about our daily lives. And data centers is the same thing. Data centers are, if you start to look at the total amount of data center footprint in the world today, they are one of the largest contributors of greenhouse emissions. They consume a lot of power. Many of them are also run on diesel generators. Very few of them use renewable sources. And if you look at the total amount of heat they generate, and the amount of cooling that is required to keep them operational, it's massive. It's massive to the point where I think if you aggregated it, it could easily add up to single digits of the world's GDP. And that just is unsustainable. If you're talking about climate change, and if you're thinking about really making sure that the world can operate on data centers in a healthy way, we have to make sure efficiency is factored in.
Yeah, I mean, I would imagine that it's not only unsustainable, like you mentioned, from an environmental perspective, but also just from a financial perspective. I'd imagine that it takes a lot of money to make sure that the rooms where you're housing all these servers aren't constantly overheating.
Yeah, absolutely. I mean, think about let's start with your personal devices, right? If you have a laptop or a phone, and if it is not efficient, what's the first thing that will start happening? Your battery will start draining quickly, which means now you're going to have to plug that phone in or laptop in more frequently to the power outlet, which means you're burning more. You're creating more energy, or you're burning more energy to keep your life going on with the phone and a laptop and such. So efficiency is not just at the data center level; it starts from the device level. And so I think in the data center, you take that example that I gave you and multiply it a few thousand times. And that's the scale at which we are thinking about the equipment that is in the data center, whether it's the servers and the storage arrays and the network equipment and all of the radios that provide wireless access. All of that collectively consumes a lot of power. Not only that, they consume power and they generate heat. Now, when they generate heat, they have to be cooled, which means you need massive air conditioning to cool it down. In some cases, you need to force the air through the circuitry so that it remains cool. That's just the amount of power that goes on to create that operational state, the service availability, because all these data centers have to be up all the time. It doesn't matter. You cannot have a data center just go down, because if you are relying on, say, a plane flying over the ocean and the data center goes down, then the plane is now suddenly flying blind, right? So there are data centers that just cannot go down, and which means that you have to keep standby power all the time. You cannot assume that the standby power will work. So in many cases, these diesel generators are constantly churning just so that if there is a loss of power, they can take over.
Sure, multiple points of failure. How has the landscape, specifically as it pertains to data center efficiency, changed, let's say in the last 5 to 10 years? I wonder if the push to the cloud has complicated it, eased it, changed it.
Let's talk about the cloud a little later. But I think if you specifically look at data center architecture, and I'm talking about the circuitry and the components that go inside a data center. I think at a very basic level, data centers are mostly silicon-based, and I think silicon has improved. The chips that we put into servers today are a lot more efficient than the chips of 20 years ago or 10 years ago. So they are a lot more capable, but they also are a lot more efficient. What has also happened is software approaches, so virtualization as an example, has enabled you to take some of the multitasking capabilities of the silicon and create denser environments, so you don't have to produce as many physical servers in your data center to generate the same amount of capacity or performance. And we've done some studies that kind of show you the amount of efficiencies you can gain by taking a software plus hardware approach to data center design. And then finally, data center cooling and power is also become very efficient. There are now all of the infrastructure that goes into data center is what we would like to call as software defined. You have better ways to monitor it. It can, in fact, control the power. There's different rack standards that have come into place that enable a better airflow. They also have better standards of how the placement happens in a data center. So you can almost think of it as that the entire data center design inside out has gone through significant overhaul in the last few years. And now let's talk about cloud. Now, the reason I said let's talk about cloud later is because cloud is just in a lot of ways, we think of it as a deployment model and an operating model. By itself, cloud doesn't mean efficient data centers. In fact, there have been rumors in the past that many of the service providers that offer cloud services run dirty data centers. And what that means is that they're just running data centers in an inefficient way. Now, without naming names, we can keep that for the side. But by fact of the matter is, just because you are offering a cloud service doesn't mean you're operating efficient data centers. They're two separate activities. Now, where the service providers are careful in making sure that data centers are efficient is because ultimately it's all about margins for them. So if you're operating inefficient data centers, then you're effectively throwing money down the tubes, right? So you want to be able to make that money, you want to be able to save money. And this is why you see a lot of these providers making bets on renewable sources. They want to be able to switch to alternative energy sources for their data center. They want to invest in more, top of the line, cutting edge technology for efficient data center design. And so it's top of mind for everybody. It doesn't matter who that entity is.
Yeah, and I would imagine too, if you're a provider, a cloud provider, for example, and you're going to be operating a massive data center, I would imagine that some of your customers are probably going to be asking you questions and being curious about how your data center is run, especially if they're an organization that has environmental goals in mind.
I think that's a fair point, and in fact, I've heard a lot of enterprises make that requirement as a part of their RFP when they solicit bids from cloud providers. I know cloud providers themselves are definitely making sure that their data centers are more efficient going. And let's also say that on the whole, service providers operate much more efficient data centers than, say, the general corporate IT environments, because for them, the data center is their business. Whereas
Right.
for a lot of companies, data centers are just a means to doing the business versus, for the service provider, they absolutely rely on that data center for delivering a service. So, and whether it is a service provider like Facebook that offers a very consumer-focused service, or versus, say, Microsoft or Amazon or Google that provides more, sort of a business-focused service, the fact of the matter is availability is availability. People lose their mind when Facebook goes down, and people lose their mind when the business goes down. So, regardless, you have to have that data center up and running.
Yeah. So I guess, the $1 million question, probably, maybe even $1 billion question is what can, let's put the onus on, I guess, a customer, right? So if you're an enterprise, for example, and you're operating a data center just within your office, what can IT do to monitor or improve the efficiency of their specific data center?
Yeah, that's a great point. And so the first thing I would say is that awareness is key. A lot of the customers we have talked with in the past, for them, they are not able to articulate, leave alone measure the efficiency of their data center. And that's right there, that's a starting point for awareness. If you're aware of the fact that your data centers are run in a certain way, and then the next step would be to making sure that these data center efficiency metrics, mostly power consumption and the ability to make sure that your power is consumed in a way that is delivered efficiently to the infrastructure that is using it. Those metrics should be part of your operations, right? Your IT operations needs to incorporate those metrics. In a lot of companies, what I've seen is that the data center operations are divided into two groups. There is the facilities who just runs it as a independent entity, and then there is the IT operations that just looks at the servers that run on it. That cannot be the case. You need to have it as an integrated operation where the metrics can be used to guide the decision making around what are the kinds of infrastructure you are going to house. How old is that infrastructure? How inefficient is that infrastructure? Is there any wastage? Are you just running servers that are underutilized? Can you take software approaches that increase the density of those servers? Just investing in technologies that allow you to make the most out of that investment, not just from a performance or sort of availability perspective, but also just how much heat is being generated, and is that heat something you can tackle with approaches like liquid cooling. And I'll give you an example of why that is the case. It's an 80-20 rule. 80% of your infrastructure might be general purpose and efficient. 20% of your infrastructure may require extraordinary approaches because you are investing in high performance or performance intensive infrastructure that generates a lot of heat. So you may have heard that GPUs, data center GPUs, or even the GPUs that you run in your PC they generate a lot of heat, but the amount of performance you can gain from them for certain workloads like artificial intelligence or machine learning or even high performance computing or analytics, you just need that. Your business cannot run without that kind of investment. So for 20% of that infrastructure that's going to really push the operating envelope of what a data center can deliver, you need alternative approaches like liquid cooling. And in recent times, we've seen a pretty big surge in liquid cooling technologies because of the fact that enterprises are now saying, hey, we need to invest in this purpose-built infrastructure because our insights that allow us to run the business require that kind of infrastructure.
So you mentioned assessing the efficiency of your data center and figuring out specific metrics, but how does IT go about that? I mean, if you're starting from zero, how do you scale up?
So the first thing I would say is that there is a lot of information available out there. There are consortiums that will allow you to guide your approach. So you don't have to. It need not be an ad hoc approach. I would say that working in a consortium with these green data center or consortiums, and also pushing your vendors to provide. See, a lot of vendors will provide detailed, quantitative information on or specifications on how their operations how their products function. It's no different than the rating of your car, for example. All the infrastructure vendors will provide that rating. It's published, it's available, and then you can go about doing your math. It's basically taking the wattage and converting it into carbon emissions, and really looking at how efficient is it. And we've done some work on this. We have some models that allow, but most folks can do it on their own. It doesn't require rocket science. You can literally take the specifications of your servers and storage and network equipment. These are all rated, they're published, and then just go through a simple math of looking at how much, if are they running 24 hours a day? What is the total number of hours they run? What is the operating envelope? Are they running within the range of the allocated wattage? And then converting it into, basically carbon, and looking at, how efficient is it? And we have some range. And, the best way to compare in my mind is to look at real life examples. So one example we often give is, the more efficient your data center is, it's almost like comparing how many cars can you get off the road. If you were running a very efficient data center, you can compare it with, in a year, it's almost like 10,000 less cars or something, or measure it in terms of some real life numbers, like the GDP of your country or what have you. That gives you the ability to connect it with something that matters in the bigger picture. If you just look at it as how many dollars am I saving, I think it gets the job done. Don't get me wrong. You might say my data center operations is $100 an hour, went to $90. Okay, well, that's great, but think about the bigger picture. What exactly are you doing? And then the last thing I would say is that invest in renewable energy. If you have the ability to invest in other forms of, then you don't need to have a diesel generator. You have a solar panels on your roof, or you have some wind turbines or something. It's not the same thing for every company. A lot of companies might say, I'm just going to go to the cloud and hope and make sure my cloud service provider is the one doing all of that. But that's really where I would start. It's the awareness, and then taking concrete steps to measure it and then fix it.
And on the environmental point, as we wrap up here, I would think the general rule of thumb about sustainability applies, in that focus on what you are specifically using, get the most out of it as possible. So, I mean, for example, you mentioned liquid cooling, and maybe there's something at the silicon level with, efficiency cores over performance cores, but what's happening with the hardware? How has the specific hardware technology evolved to factor in the importance of efficiency in the past, few years?
That's a great point. And, I think in recent times, we have been introduced to the fact that silicon cores or silicon subsystems can operate on a low power mode when they are not being used, and when they are being used, they can go into that turbo mode and really deliver. That ultimately comes down to what kind of hardware, what kind of investment you're making, and this is what when I said that you have to be up and current with your investments. One of those areas of investments in making sure is that the most current silicon be powering that server or storage area, because then those efficiency cores and performance cores are blended into the die, and then that allows you to, I could give you a very simple example of a consumer device. The phones that we carry around, or the latest laptops that we carry, without naming names, are all designed with that kind of a structure, because again, people want to be able to extend the battery life as much as possible, and you cannot have a long running battery life if everything is performance cores, right? You need to be able to. Now, keeping in mind that just the hardware alone doesn't do the trick. You need to have software that can work with that hardware and be able to manage the silicon in a way that the workloads that are running on that silicon are able to adjust as well. So it's like pressing the gas pedal, right? When you press the gas pedal, there is a little bit of a delay before the engine realizes that it needs to go into that mode, and then you can, if you have a turbo engine, you can hear the turbocharger kick in. It's the same with silicon and software. When you move a workload from being a low power workload to a high performance workload, it takes a little bit, and the software is where it gets managed. And the investment is, you have to invest in the stack, and the stack is the infrastructure hardware and the software. They are married so that they can function in a sort of a seamless way and deliver that experience to the business. The key word here is seamless. It has to be seamless. It has to be transparent. Otherwise, you cannot have the business saying, "Oh, I'm going to wait for the software to really start performing again," and you cannot have delays. So
right. Well, thank you so much, Ashish. I think this was a really great overview of the concept of data center efficiency, where we are now versus where we were previously, and what sort of steps IT can take to address data center efficiency, within their own offices, within their own companies. So thank you so much. I really appreciate your insights.
My pleasure. Thank you for having me on the call.
And thank you all so much for watching this episode of Today in Tech. If you like this video, please give the video a thumbs up, and you can subscribe to our YouTube channel, IDG Tech Talk. Hit the bell icon so you're notified every single time we post a new video. If you have any questions, comments that we didn't address, please do let me know in the comments below, and I will do my best to get back to you. Thanks again for watching, and we'll see you next time.